Hello dear students, welcome back once again to this video tutorial class. Today we're going to start a new chapter, that is chapter 10, correlation. Okay, so here we are going to solve only one type of correlation, and I'll tell you why later. Alright, so before we go ahead and start solving the sums, I just want to talk about a little bit of what correlation means. So the name itself says like co and relation. So therefore it is a relationship between something or the other. All right. So here in statistics here, this chapter, correlation is talking about the relationship between two sets of data. Okay. So the one set of data affecting the other data. For example, if we talk about demand and supply. So demand and supply are two sets of data, two variables, demand and supply. So how is demand affecting supply and how is supply affecting demand? Yeah, so this is what we are going to study in this chapter, the correlation between two sets of data, be it income and expenditure, be it demand and supply, be it price and demand, or in the textbook you will see very good examples are given here, the consumption of junk food and obesity. So all these things are correlation, you have a relation between two. So there are different types of correlation. We have positive, negative, linear, non-linear, simple, partial, and multiple. I'll be explaining those in the class. However, one thing that you have to keep in mind is that when we are solving correlation, we will always get the data in either positive or negative, right? That is, it will be either, it will range from +1 to -1. So it will be positive 1, or it will be positive -1, or less than that, or more than below 1, but it will be in positive, and below 1, and again it will be a negative. So that way we can say that okay, it has a positive relation, and or the other way, like it has a negative relation. So when we say positive relation, we are talking about like if the change in the value of variables, a positive relation refers to the same direction of change in the value of variables. So in other words, if, for example, if the value of x increases or decreases, the value of y increases or decreases respectively. So if we have, say, two variables, x and y, if x is increasing and y is also increasing, therefore we can say it is a positive relation. Okay, and the other way, if x is increasing and y is decreasing, then that means it is a negative relation. All right, so some of the portion from this chapter is omitted for this syllabus, for the exam. And therefore we will be solving only one type of correlation, although there are three types of three methods to calculate correlation. That is scatter diagram, Karl's Pearson coefficient of correlation, and Spearman's rank correlation. Spearman's rank correlation. So in this chapter we will be discussing only one topic, that is Karl's Pearson coefficient of correlation. Okay, so let us first learn the formula to how to calculate this. Let me just change this for a bit now. All right, so let's first learn the formula of how to calculate Karl's Pearson coefficient of correlation, and after that we'll start solving the sum. So this Karl's Pearson coefficient of correlation, this method is developed by Karl's Pearson, and hence it is named after him. Okay, Karl's Pearson's coefficient of correlation. So it is denoted by R. Okay, and the formula to find out is sigma xy minus n into x into y, that is mean, divided by, square root sigma x square minus n mean square into sigma y square minus n y mean square. So this is the formula to calculate Karl's Pearson coefficient of correlation. Okay, and here there are different methods. We have actual mean, direct assume mean, and step deviation method. So we will be solving the sum in direct method. Okay, so this formula that I've just given you here, it is for direct method. All right, let me just write down here. Okay, so in this chapter, we don't have much. We have, I think, nearly 3 questions based on Karl's Pearson coefficient of correlation. That is question number 3, 4, 5, and 6. And the rest of it are rank correlation and scatter diagram. So since we will be solving only one method, that is Karl's Pearson coefficient of correlation, we will be solving only question number 3, 4, 5, and 6. All right, from the practical question. So let's solve one question, and the rest of it, I'm sure you will be able to solve by your own after watching the tutorial. So please pay attention while you watch the tutorial, and after that you solve the sums by yourself. Okay, so we'll be solving one question now, and we will be solving question number 4. Question number 4. Okay, so I'll be changing the background here so that, okay. All right. Okay, let me make the table here. So it is quite easy, right? So what you have to do is you have to make 5 columns. One, 2, 3, 4, and 5. So what you need to do here, first thing, question number 4. Question number 4, from the following data, calculate Karl's Pearson coefficient of correlation. So here we have x variable and y variable, right? So we have to write down here x, and we have to write down here y. Okay. So what you can, first let's write down the x variable, everything that is given in the textbook. It is 79, 68, 78, 61, 89, 96, 69, and 59. Now what you have to do is you have to find the square root of this, okay? Just square this value. So 79 into 79, you should get 6,241. 68 into 68, 4,624. 78, just like that, you have to square it up, okay? Everything. 6,084, 3,721, 7,921, 9,216, 4,761, 3,481. So this is x squared. Now you have to write down the y value. Y value, let's write down 136, 123, 125, 108, 137, 156, 112, and 107. So this one as well, you have to find the square root of this. Square of the y value here. So 136 into 136, you should get 18,496. 123 square, 15129. 125 square, 15625. 108 square, 11664. 137 square, 18769. 156 square, 24336, 112 square, 12544, and lastly 11449. So this is the value, square root of all the y variables here. The last one, you have to find out the sum of x and y. Okay, so x and y. So 79 into 136. You should get 10744. Next again, 8364, 9750, 6588, 12193, 14976, 7726, 7728, and 6313. Okay, so once you're done writing all this value, what you need to do now is you have to find the sum of all this value. Okay, so done till here. Okay, so here sigma x, your value, if you add up all this value, you should get 599. Okay, sigma x square, if you add up all this value, you should get 46049. Next is sigma y, you should get 1004. Sigma y square, you should get 128012. Sigma x and xy, you should get 76656. Clear? So please add up all this value, x value, x square, y value, y square, and xy. So in the formula, you have x and y, that is the mean of x and y. So let's find out the mean. Okay, x mean is equal to sigma x by n. This is how we find the value of mean, right? So here 599 is our sigma x. Our n is the sum of the items here. 1, 2, 3, 4, 5, 6, 7, 8. So our n is 8. So if you divide this one, you should get 74.875. Okay, keep it like that. Now find y mean. That is sigma y by n. Sigma y, we got 1004, 1004 divided by 8. You should get 125.5. Clear? So now we have everything. What we will do now is we will put this value in the formula. So R is equal to sigma xy minus n x y, that is multiplication. Okay, oh my god, divided by square root, god, sigma x square minus n x mean square into square root sigma y square minus n y mean square. Alright, now let me just change the background. Okay, so you have all the values here. So what you can do is you can just denote this value. Okay, put this value in the formula. Now sigma xy, we got 76656. So you can write down here 76656 minus n is 8 into our x value. It is 74.875 into y value is 125.5. So you can just put, multiply this first. Here, let's put this again. X square is 46049. 46049 minus n is 8 into 74.875 square, okay, into sigma y square is 128012. 128012 minus 8 into our mean, y mean is 125.5 square. Now 76656 minus 8 into, if you add up this value, 7.875 into 125.5, you should get 9396.81. Clear? So here again, let's write it down one more time. 46049 minus 8 into, if you square the 7.875, you should get 5606.27. Clear? Next, 128012 minus 8 into 125.5 square, you should get 15. Okay, it's 15150.25. All right, now let's proceed again. So 76656 minus 8 into 9396.81, you should get 75174.48. So don't copy right now, okay? You can just watch it, and then after that you can solve the answer by yourself. 46049 minus, if you multiply this, you should get 44850.16. Okay, into 128012 minus 8 into 15150.25. If you multiply this, you should get 126002. Clear? Now, if you subtract the 76656 minus 75174.48, you should get 1481.52. If you subtract this value, you should get square root 1198.84 into, next, if you subtract this value, you should get 2010. Okay, after this, you have to find the square root of this one. Square root of this should be 34.62. Okay, square root of 2010, it should be 44.83. Now 1481.52 divided by, multiply this 2, you will get 1552.01. Alright, after that, if you divide this one, you will get 0.95. So this is our correlation. And you can see that it is positive. So in the textbook, if you look into question number 4, the answer is given R is equal to minus 0.95. Alright, so that here the answer should be plus 0.95. That is, the correlation should be positive, not negative. Okay, we have solved it just now, and then there's no negative sign. Therefore, you can please correct the answer in the textbook. All right. So this is it. This is how we calculate correlation. It is pretty simple. It's just that it has very big values, and therefore you will need calculator to solve it. And we permit calculator in the example. Therefore, I don't think you will have any problem solving this. So question number 4, I have solved it for you all. You watch the tutorial and try to solve it by yourself. So question number 3, question number 5, and question number 6. All 3 questions, that is question number 3, all right. Question number 3, 5, and 6 are homework for you. Okay? So you just have to do the same way and put in the formula and then substitute it. Substitute the value in the formula, and you will get the answer. Clear? So with this, we have come to the end of chapter 10. I will not be making any more tutorials for Spearman rank correlation because it is out of the syllabus for this year. So we only have one method to calculate, that is Karl's Pearson coefficient of correlation, and we just solved it now. Yeah. So I will be taking another topic in the next video tutorial. Okay. So take care and please do your homework.